everybody, it's GlitchedPixels here, and we're back with another Minecraft live stream. So, yeah, let's just get this one started. So, let's see what we got here. Yeah, live on YouTube. Thanks to all these people. Yep, that's good enough. The rain's a big issue on the server, which I really hate. I just really hate a lot. Thank you. See if there's anybody on yet. Low video output quality. That's probably a problem. But video output's not working very well. Okay, I think we just have to deal with that, honestly. Yeah. Let's see if anybody will join. Here's what I'm gonna do. I'm gonna tweet the link. Yeah, I just tweet it. I'm live and play. Okay, I tweeted it. Let's see if anybody joins. Yeah. And obviously the link to Discord, which I should post too. Yep. Okay, let's see what's on plan today. So we got these plots, you see? These awesome plots. Now we just need to put something in the plots, or maybe get someone else to put some in the plots. So that's really stupid. Anybody? Okay, I don't want to know that. Class. basic oh, that's such a good roast. Oh god. So all this is unclaimed wolfland. Huh. F list. Wolfland. Let's see who's online. Oh, AFK, damn it. I'm the only Wolfland guy. Yeah. Any of my old friends still on? Nope. Apparently not. Ivan, voice general. Yeah. Okay, we're live. Still, right? Yeah, we're still live. And we need more food. So, yeah. Let's just, so, technically, I don't own this, so we can cap that area off. But I own all of that. We did dig out all this. Yeah. How many people are on the live stream? 1, and the live stream is currently lagging. That's sad. Small loan, eh? Anyways, so funny. So I don't have access to this either, so let's plug that up. That's a basement, so I need a vote. Yeah, let's just vote. Because we need money. Let's open it in Chrome. Or I use something called Brave, which is a really good browser, highly suggested. Oh my god, it's... Does it say it will... What does the chat say? It will give me 50, but voting only gives me 40. That's like really stupid, right? Let's see, shop that, okay, good. Completed that, and now we log on to Minecraft MP. GlitchedPixels. Bellingnor is back? Cool. Mindstatus.net, and then we're voting here too. Guys, just please help me. Come on the live stream. I'm not gonna kill you, okay? Not that dangerous. Huh. Okay, let's do Minecraft servers now. And we'll be all done with all the voting. Voted. Okay, we vote everything already. Okay, we got some cash, money. Yeah. Let's see, what's that song? There we go.
And now we will hear a 2-minute closing statement from German Supreme. I'll be accompanying you on my strat.
My name is Vermin Supreme, and you can vote for me. For president if you want, and my name is Vermin, and okay. Do you still stand by your pony pledge? Yes, I do. Breed ponies with all. Turn all that pony poop to methane gas. One more thing, Jesus told me to make Grandma's very gay. He's turning gay, turning gay. Alright, okay. Turning gay. And all the ungay is melting away. He's turning gay.
Ha ha ha.
Our instincts are there.
Hello.
What's up, man?
Life? Yeah.
Yeah.
Yeah, dude.
What's up?
Not much. The sky.
How'd you find out about this live stream?
You posted it in chat.
Right. So,
Right on.
yeah.
Are you playing like factions or something right now?
I'm currently playing on webcraft.co.uk, which is a friendly faction server, but there is occasional stuff.
Okay. I was gonna ask you if you could press F3 because I want to see what you have real quick because I do want to help you because apparently your stream's not running at 60 FPS. Like.
Yeah. Like, what'd you say?
So, if you press F3, I'll see your graphics card, and I was wondering, like, what you use.
Yeah.
Oh, hey.
Hello.
You guys still on that server?
Yep.
Alright, I'm gonna join. Sorry, I had to go that night.
Yeah. It is.
So you guys are like a democracy.
No. So, right now, I'm just like messing with things in factions.
Huh. Okay. Merc.
Yeah, what?
He's just running off of his CPU, which is a Core i7 7500K.
Ooh.
I am the dab daddy.
Wait, what i7 is it?
7500K.
Ooh. Wait, 75. I don't really know too much about that, but I think it's pretty good.
Yeah.
Do you know your graphics card?
It is embedded.
It's an embedded graphics card.
Yeah.
Are you on a laptop?
Yeah. I'm not on my desktop right now, so I apologize, but this week we'll be live streaming for about 5 days straight, throughout Thanksgiving week, so, yeah.
Ooh, nice.
Ooh, okay.
So, not much work to do this week for about 5 days straight.
Oh, there's...
I have an i7, but not like, I think it's the old one, like the oldest one.
Okay. Merc, he has
I'm on an i3.
He has an Intel HD graphics 620.
Yeah, and then it's running on Optifine.
I have a 477, an i7 47.
Oof. What do you have in your desktop?
I have a Ryzen, AMD Ryzen, and also a 1080 Ti.
Shit.
Yeah, that's pretty nice.
Fucking, what do you mean pretty nice? He probably has the Ryzen 7 to be honest.
Yeah.
He said
Okay.
he has a 1080.
Yeah, he has a 1080, then he probably has a Ryzen 7. Am I right?
1080
Or a
Ti.
Ryzen 5.
Yeah, because I'm running low on graphics cards. Because most of them are dedicated to mining crypto.
Ooh, wait, what's your mining, dog?
Huh?
What coin you're mining?
Ethereum.
I would mine Ethereum Classic, but you can do whatever you want.
I actually, wait, do you mine as well?
Yeah, I do.
Oh, cool. We got a miner in the chat.
Yeah.
So,
Why the hell am I getting 0K?
what do you think about the new Byzantium?
Byzantium? I haven't heard of it.
What do you also think about proof of stake?
I kind of like proof of stake, but then I kind of don't at the same time.
Yeah, but yeah. What were you trying to say?
I was wondering, like, is there large amount of usage for network for proof of stake? Because the way I kind of think of proof of stake is it's like actively communicating with different nodes to try to like figure out which address it needs to like vote on, kind of thing.
Not necessarily. I mean, I don't think so. Maybe.
Yeah, I just thinking that was the way it was kind of work, but when I think about it, they just take the outputs of the each transaction and then just kind of figure out which one's the largest value and then vote based on
Yeah. I've been listening. Yeah. I've been listening to the dev live streams. They stream every Friday. But I think so this week we'll be meeting 30. You guys can see it in the GitHub. It's github.com/ethereum/PM. And they were talking about Casper, but I have not read the Casper white paper yet, so I honestly do not know.
I read part of the Casper white paper.
Yeah.
I honestly have no idea what you guys are talking about.
We're talking about cryptocurrency.
Yeah, I kind of like keeping proof of work for Ethereum, but I don't know. We'll see how it goes.
So
I'm kind of an Ethereum classic fan.
Oh. So
it's a cryptocurrency.
Yeah, it's a public.
Mostly the reason why I like Ethereum Classic is because it's really easy to buy small units. Like you can buy like 20, and you won't spend like $100,000 or something.
Well, but nobody uses Ethereum Classic.
Well, it has a billion market cap. It's not too bad.
Okay, if a company, let's say my startup, and I want to hold an ICO and I want to launch a product on the blockchain, I'm probably going to choose Ethereum because no one ever talks about Ethereum Classic. I mean, it's just people kind of see Ethereum Classic as just a bunch of people that got pissed off at the DAO.
Yeah, that's true.
I understand the DAO was a big hack, but those people deserve their money back.
I don't think it was the wait.
The DAO?
Yeah, the DAO, that thing. It was also part of the fact that they didn't like the DAG increasement, and they changed the way the DAG works so it has like a constant set amount, or it's slower.
Yeah.
Because of the Ice Age thing that they set up.
Oh yeah.
And it was kind of funny watching the Ethereum chain like slow down drastically.
Yeah. Well, I'm in support of off-chain scaling. Have you ever heard of Raiden network?
Raiden?
Yeah.
A little bit. Isn't it like the Lightning network?
Yeah, similar. So you have to, but it does not support Ether. It supports ERC20 tokens. So in order to send Ether, you have to use like a wrapped token, Ether. But yeah, we're talking about Ethereum. So the way I see the Raiden network is it could be used for everyday transactions because you don't want to publish you buying a coffee or you paying for electricity every single time to the blockchain. That's pointless. So so what you do is that you deposit a certain amount of tokens and then you sign transactions to other peers using like a peer-to-peer network, and then at the end you settle those transactions, which is
so similar to the Lightning network.
Yeah. And it's so game-changing that someone could replicate the Lightning network in Ethereum.
Yeah. What do you think of SegWit?
SegWit. Oh, I'm kind of conflicted on SegWit. So SegWit, you're talking about the 2x SegWit?
SegWit is Witness. Both.
I'm kind of mixed. I can't really decide because it's I'm like very security and like oriented, but I also care about the scalability of the blockchain. So I'm pretty mixed feelings about that.
Yeah.
What do you think?
I like it. It's a great concept. Like, I'm not gonna lie. And I've heard a little bit about Seg Signal, but not too much about it.
Yeah.
So you can like vote based off of like information.
Yeah.
Off of the way it works. Anyhow, but I kind of initially was a emergent consensus supporter.
Yeah.
Bcash. Well, I kind of wasn't when Bcash started to make a fork. I wasn't a supporter,
Oh yeah.
but I was running that software, and then I converted over to SegWit after I read a bunch about it. So.
Yeah. What do you think about Bitcoin Cash? I just want to know your opinion about Bitcoin Cash.
Well, as you know, it's the increasement in the block size.
Yeah.
And there's some other security information that goes along with that. They fixed some kind of bug with it. I'm not sure too much about that, but I like it. The transactions are really low cost, like
Oh yeah.
really a long time ago. But I don't really have too much take on it. It's not very well accepted by a lot of places
Yeah.
yet, but that's expected to grow.
Yeah, Coinbase said that they would never support it, but they said, we'll see about the market. We'll see about the market.
Yeah. And when you kind of looked at it, spiked to 2,000.
Oh, yeah.
Kind of a waker up, and it almost, it switched between Ethereum. Like, Ethereum wasn't the second one down.
Yeah. Currently, Bitcoin Cash is number 3, but they're always fighting against each other, the market caps.
Yeah,
but also think about it. Every single person that has owned Bitcoin ever in existence, they just got free money, right?
Yeah.
So if you own a ton of this Bitcoin, then you just got a ton of Bitcoin Cash, which is amazing.
Yeah. Unfortunately, I don't own a lot of money in Bitcoin. I mostly keep on altcoins.
Yeah. Like, what about Ether?
Yeah, Ether. But now Ethereum Classic. For a while, I had all my money in Ether.
Yeah. But right now Ethereum's gonna hit like 500 soon, and
It is?
yeah, it's like 350. It was like slagging because of the Metropolis fork, and people were like, meh, I don't really like it. But then there was a lot of talk about Ethereum and smart contracts, and it went all over the news again, and then the price spiked again. So
yeah.
What do you think about Filecoin?
Filecoin? I haven't heard of it.
So Filecoin is, do you have ever heard of IPFS?
IPFS? Maybe a tiny bit.
IPF, like the files.
I don't know what it means.
Like it's like Swarm. Think of it like a swarm.
Alright.
So essentially, it allows users to publish on a decentralized blockchain. So when you publish, that data is permanent, and then essentially, it converts that data into a 32. It converts it into a 128 byte length hash, and then you take the hash and you can publish that hash anywhere you want. So it's really useful in like decentralized data and stuff like that. So Filecoin, which is the company that makes Filecoin is Protocol Labs, which also make IPFS. They said, why don't we take IPFS and pay people to store data? So Filecoin, essentially, instead of mining cryptocurrency, the way that you mine Filecoin is that you store data for other users.
So similar to the way SafeCoin is, right?
Well, you get paid. Well, but users have to pay money.
Yeah, that's essentially SafeCoin.
Yeah, I guess you could say it like that. Yeah.
Yeah, it's kind of like a transaction fee, but it's like it doesn't work from a specific person. It's from like a group of people.
Yeah.
Because you're all storing different shares from different files. Like one guy might have a file that needs 20 shares. They send that to 20 people, and you pay everyone.
Why did they kick me?
What was that? I couldn't hear you.
It doesn't matter.
No, we want to hear what you say. This is a live stream.
No, I said, why did they?
Your mic is cutting off.
Where are you, anyways?
I'm just wandering around. I'm gonna build a bank here, maybe.
So yeah, so similar to that is, have you heard of Tahoe LAFS?
Tahoe, what was that?
LAFS.
Tahoe LAFS?
Yeah.
Oh, this program.
Yeah.
Yeah, this is basically IPFS, except that it's more distributed.
There's no payment system.
Yeah.
So, which I actually think is kind of a good thing, because a few providers on this one network I'm involved in and provide quite a bit of storage has like 3 terabytes. And over long-term tests, I can store a 200 megabyte file, and it never degrades.
Yeah.
It hasn't degraded yet.
This is what my company uses for storage. So when yeah, so essentially we have a bunch of stuff, but we might switch over to a private testnet of Filecoin. So we basically don't need to pay Filecoin. So we host all our own data, and we just pay Filecoin to the servers, which obviously who owns the servers? Us, so we're just paying to ourselves. Imagine, yeah, we're just using imaginary Filecoin, so yeah, testnet.
Yeah. I still like parallel IFS though.
Yeah.
On the one network which is running through this anonymizing system is slow, but I'm sure it's really fast on ClearNet.
Yeah.
And it has built-in SSL for its connections.
Have you ever?
It's all based off of DHT, so.
Yeah. Have you ever heard of CJDNS?
Yeah, I actually use that quite a bit.
Oh yeah.
I use it to pair 2 of my computers together.
Peer me, bro.
Alright. Send me your data file thingy.
Yeah, hold on. Oh, CJDNS isn't installed on this computer.
Alright.
Do you run Linux usually?
I run Mac.
Oh.
My server's Linux, but my laptop here is Mac.
That makes sense. Yeah, most people in my company prefer Linux actually for some reason. So
yeah, Linux not too bad.
When we hire people, we usually look for CS skills and blockchain skills and then so. But then we also, one of the things is like sysadmins. We are thinking of hiring a sysadmin, and it's like, oh sure, sysadmin. And I was like, I don't really know that much, so I'm not sure what I should look for in as for that.
Yeah, when I got my home server set up and it didn't have the DHT properly configured, because there's apparently some bug with Ubuntu server that causes it to not set up DHT, or on that hardware for some reason it does that. So I had to manually set it up through like a monitor and then get CJDNS and SSH through there and then set up the DHT to work properly.
But nowadays, like CJDNS is pretty much dead. Like but I had this like weird idea. Why don't we port all the blockchains to CJDNS?
Meaning?
Like we open up our like servers to CJDNS so that users can basically find each other on CJDNS, and all the existing blockchain programs ever, like every single one, Substratum all the way to Internex, all the way to every single blockchain application possible, and every single DApp possible, and we just host like a bunch of blockchain and blockchain utilities. We host like Swarm, IPFS, and then so that was one of the ideas I proposed in the Hyperborea documentation, and then nobody responded, and I think Hyperborea is basically dead.
Yeah, it's not really too much of a network that people are actively involved on. It's kind of just like the software is released so people can build their own, like between private computers. And it's especially good if you have actual physical hardware, like a radio antenna or other things.
Yeah.
So you can pair like a house and another house, or like a phone or something miles away from each other without needing anything. Like you can pretty much set up your own cellular service if you have enough radio.
So one of the things is that I talked about is that Stratosphere Technologies, when we were building drones in the early stages of the company, I was like, why don't we hook up CJDNS to the thing, and that was like a major idea for a long time until we dumped that idea. So yeah.
So like have the drones be hooked up to CJDNS. So if you want to communicate with blah 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 drone and there's this many drones around them, you have them peer together so you can send them to.
So like each.
I thought of a similar idea a while ago.
So then we, yeah. So basically we attach like a cheap like Raspberry Pi Zero to like 433 megahertz, 2.4 and 5 gigahertz bands, and then once they're running, we just like hook them up as Wi-Fi connectors and send them encode radio waves as CJDNS. You know, hook it up to Linux using like
the raw 802.11 protocol.
Yeah.
Essentially.
And then that was the idea for a very long time until we started selling into commercial, and then that idea got dumped because, you know, we didn't want to deal with that anymore. So yeah.
Why wouldn't you have that?
I don't know. It was just way too difficult for clients to deal with, and that was one of the.
It wouldn't be too hard because you can. Okay, so wait, do you sell like the controllers like separately, or are they the controllers like provided?
It's the controller is software.
So the software. But no, what's your actual communication to the drones is what I'm saying.
So we just have like we just use like IoT conventional devices like 4G LTE, but that's the best we can do right now.
I wouldn't do like the LTE bands because those are mostly commercial type.
Yeah, and spotty.
Use the and spotty. I would be using the 5 gigahertz or 2.4 gigahertz bands because those are unlicensed.
Yeah.
And there's a lot of devices that I've seen that support Ethernet cables that you could have antennas for. So you would have like a antenna cell online that connects to another antenna, and you'd point them at each other, and they would have their software would be able to communicate. And then it would decode all the information and make it compatible with the Ethernet cords, so you can hook them into other IoT devices, Raspberry Pis.
Yeah, that seems like a pretty interesting idea.
And then have an adapter, like having a 2 Ethernet port adapter. So let's just say for the moment the drone software is incompatible with CJDNS.
Yeah.
Put DHT on the Raspberry Pi, which then proxies the information over to the DHT connection, and then out through CJDNS, which is controlled by the Raspberry Pi and the antenna that you attached.
Yeah.
And for the software, it just has the standard communication system, and then it just interacts with it like a normal device over the internet would be.
Yeah, that seems pretty interesting. That might be something to consider in the near future. So.
Yeah, and it would be, and since CJDNS handles out the routing, it would be really efficient for data. Data.
I mean, they
have to worry about like reading information.
So they automatically peer. So even companies that like they don't companies like they have separate drone networks, they can still send data to each other even though it's like a trustless system.
Yeah.
So that might be something to consider, but as of now, we don't currently have the ability to do that, so maybe by like Q3 of next year or something.
Yeah, it shouldn't be too hard, but you still have to have the Raspberry Pis.
Yeah. Which makes sense. And
if there wasn't any devices, because you know CJDNS auto peers, right?
Yeah.
If there's any devices that were to peer, like other drones, you'll just let them peer because the software will handle out the authentication and who to trust.
Yeah.
For controlling the drone. And you wouldn't have to worry about too much encryption, so that's a plus, I guess.
Yeah. Yeah, but mainly what we do is that we set it up as a Linux drone. So, and then the clients can customize sensors, and then we sell them like a complete like system along with like, and then we basically shove on like some stupid SIM card, and then that's how they operate it. So if they want, like, let's say they're mapping an area, they can just attach a couple cameras and then program it, and then that's basically it, and just uploads over like Verizon Wireless or whatever that they want.
Or you could end up like attaching IP cameras on there, and then have the information, because some IP cameras support FTP servers. You could like send data out to an FTP server.
Yeah.
Through CJDNS, like that connection.
That might use too much battery.
Yeah, would be. Or you could just record it. That's just an idea on my. I would like to try for a device.
Seems interesting. So what are you doing right now?
I'm just playing a game.
Cool. What are you other people doing?
I don't know.
Yeah. Let's see. Think of a discussion topic. So, have you guys seen the latest update to Minecraft 1.14?
No.
So, it's called the Aquatic Update, and I think it's something relating to underwater. From the interview at Minecon Earth, Jeb mentioned that there would be fish, and the fish would be actually like in the water, so you could see fish in the water, and they would also swim, and then you could pick them up with a bucket and transfer them somewhere else.
Seems cool.
Yeah. He also mentioned kelp, coral, underwater structures, and dolphins, and possibly other things underwater. And also, the ocean monuments might have a revamp, so that's also an idea. Yeah.
Something to mention about Filecoin is the fact about like storing it permanently in the blockchain. It just seems kind of like it might have some problems storing data permanently, because it's accessible by pretty much everyone. Like there's an expiration date on it.
So they're building a separate blockchain. It's not built on Ethereum.
Yeah, but like a separate blockchain, and
it's private. It's encrypted.
Yeah, even though it's encrypted, but it's still kind of there.
So
it's the encryption for the data.
I think it's on the white paper, filecoin.io, but essentially they have it so only the user with who submit the tokens can retrieve it. Also, it prevents DDoS, because every time that you want to request the file, it charges a tiny amount of Filecoin. And so miners are basically rewarded for storing the files, and then the miners are paid every time that the data is wrote to or read from, and the faster that they can write or read, the more that they get paid. Which is a pretty like that's like capitalism 101. So that's obviously gonna start some competition. You know, like who can start.
And then like price metrics for how.
Yeah.
Like what are the amounts per read? What's the average per read? Like, what's the price per megabyte or gig or whatever it is?
Yeah, there's no set price. It just ultimately depends on your region and your like where you are in the world, and your connectivity to other miners, and the speed of internet. So yeah.
Okay, so now that I kind of understand this, so it's not like in a blockchain where it's all like stored on a copies made on every node. It's kind of using the shares system, where it has shares are sent among every different miner.
So like they're kind of like split up into like several dozen blocks, I guess, and then those blocks are distributed like multiple times redundantly across the network, and each miner is paid accordingly.
But what if someone puts the data on the blockchain, right? And and they don't access it or do anything, does it just stay there on forever? Or expiration time?
Oh gosh, I don't actually know. I have to read the white paper. Again, I don't honestly know about that. I'm assuming it's probably going to be charged, but I don't know.
But what happens if that address or the account address thing
Like
runs
shuts
out of coin?
Then I guess like the miner has the right to delete the block.
Wait, or the share.
Yeah.
It
So
would have to be the share, because if it was a block that contained other data, they would have to delete the rest of it.
Yeah, so I think they can delete it basically. That's my assumption.
Is that handled by the client? I guess it would be handled by the software, because you wouldn't really know which
Yeah.
share file.
So the idea is that someone, even a kid, can just plug in a Raspberry Pi, add a couple terabytes, and make a couple bucks for allowance, and then sell it to Bitcoin and go on Amazon and buy some cheap bike or something. I don't know. Yeah. That's what my cousin told me, so that's what he's doing.
Wait, can I hear that sentence again?
He's mining Filecoin so that by plugging just plugging like those Pi Zeros with USB extenders, and plug in a bunch of terabytes, and then he's mining the Filecoin and selling it for Bitcoin.
Yeah, it seems like an interesting idea.
Yeah. Now, as of now, the code is currently beta, so it's a testnet, and the Filecoin network has no real value because they just held their ICO, but they should launch sometime in early 2018.
Yeah.
So you can sign up for the early miners program. You just download software, you select which hard drives you want to enable, and then you type in your Filecoin address, and then you make money. That's essentially how it works. It's so easy. Sounds too good to be true, right?
No, I know how it works. Don't worry. I understand. I was just thinking about one thing.
Yeah, but the implications go very big because.
So, does the software have like FTP, API, so you can connect to the FTP server and write data and stuff like that, and it will save a cache of the current data, or?
No, not as of now.
Well, that's one of the things that I really love about Tahoe LAFS, because you could open up on my one server. I have set it up so I can have a virtual FTP drive.
Oh.
And that works with an SMB share.
And it's connected to Tahoe.
Yeah, and then it's connected to every computer in my whole house. So I can go on my laptop and go on there and hit the Tahoe LAFS FTP, not SMB server, which then runs over to the server that's somewhere else.
Yeah.
House, that then goes to the virtual FTP file system, as you can say, and then interacts with Tahoe that way.
I see.
And data doesn't really, it does have an expiration, but the data doesn't easily get degraded over time.
Because it's always being replicated and self-improving.
Actually, no. If nodes go offline and you haven't updated it, which I set mine to automatically re-update, where you kind of have to tell the Tahoe network to repopulate the shares. So this is a garbage collector, so if people don't have a system that runs that, well, let's say your server went offline or if it got taken down and it had that software that was running to always refresh that data, it would slowly degrade away and get just destroyed away from the network.
I see. So is there like a command? Could you just like cron tab that?
Yeah, I cron tabbed mine, and it will rerun the whole directory that I store my stuff on and all the subdirectories.
How often do you do it?
I think I have it set to once every day.
How long does it take?
I think it takes about 5 minutes, maybe.
I see.
The network that it's connected through is kind of slow, so it takes longer here. It'll take probably 30 seconds on a standard clear net.
I see.
I don't really know. I don't count it often because I don't really look.
Do you run on CJDNS or?
It runs through I2P.
I2P.
Have you heard of that? Otherwise known as the Invisible Internet Project.
Yeah, I heard of it. It's a thing with the weird man, right?
Yeah, I pretty much know all the details about it.
So tell me more about I2P. How does it differ from CGDNS?
It's designed to be like an anonymizer, darknet, whatever you want to call it, but
like a VPN?
I want to say it's like a VPN because really all a VPN is just a bunch of networks or a network that you can communicate with each other. So the IP addresses are base 64 or base 32 encoded destinations, which then correspond to links in the network. Like how CJDNS has links, but their links are populated by DHT. This one's populated through flood fills, which has the data for those links, which then once you connect to those links, you can get the rest of the data you need to complete the connection, and you can send TCP over it.
I see.
And, UDP, which I haven't seen implemented too much yet. So.
Yeah. That seems pretty interesting.
And there's massive amounts of other information that goes along with that process. That's just a basic sum up.
Oh.
And mix routing and other.
Yeah. Routing is pretty important in a system that massive. I imagine it's like on a scale of like Tor, maybe?
Well, let's be honest. Let's first take the size of Tor.
Yeah.
I estimate it's about 500 or so routing nodes that are the core ones that everyone uses.
Yeah.
Because I've seen it replay like nodes multiple times, and I kind of like, that seems weird. The I2P network is right around, I think, 20,000, somewhere around there. Routing nodes, and about 95% of them support large amounts of data, or actually send data, because you can turn off the feature to route other data, but it's enabled by default. And you get kind of rewarded by routing data, not by like currency or anything, but by getting more peers and getting a faster connection to the network. And it also helps with like if you're connecting to websites that you haven't visited in a while, you're interconnected enough so you could look up those addresses quicker.
So
let's keep a cache of anyways.
Yeah. So let's say there's a lot of VPN projects on Ethereum nowadays. So if there's one project is called Substratum, and essentially it's like a payment system where, let's say you have spare internet power, you can just leave your computer on overnight and then it will generate money because you're essentially a VPN and a cache as well as a server. So it takes a bunch of stuff and it caches it, and then you can also acts like a VPN. So it's an anonymous VPN via Ethereum, and you get paid ERC20 tokens for that VPN.
Seems really interesting.
Yeah.
But again, most of the more important part about it, or the important part of why it's like a VPN, is more of that it routes information outside of its own network.
Yeah.
So I can connect to Google through it, or whatever site. I2P is a little different than Tor in that it's all self-contained. Like most of the time, you won't be able to access the outside internet because there's like one or two people that run out proxy nodes for the network.
Because whoever runs out proxy nodes, they will get arrested. Yeah. One guy's proxy node just reruns it through Tor, and the other one is like I think it's a squid proxy in somewhere. I think it's like Germany. I think it's Germany.
Anyhow, I like the network for just sending data to other computers. Well, it's not too fast at sending data, but just for either browsing sites or torrenting or whatever, whatnot.
Yeah. So those people are just like lazy and they just hooked it up to like, oh, let someone else deal with it.
Well, no, that's not exactly the purpose of it. There's like there's massive amounts. I looked at the code and it's huge. The documentation is
huge.
to go with that code. Yeah.
Tremendous.
Huge. Tremendous. Oh yeah, just note that I2P's Tahoe LAFS network is sitting right about 4 terabytes of available space.
Oh, that's pretty good. How much is the total network?
It has 22 nodes right now.
22 nodes, that's...
Yeah, I think I provide, what did I provide? Oh wait, no, maybe a lot more than that. I'm still scrolling through the list. Let me look here. Yeah, that's quite a little bit right now. I want to see if mine's on there anywhere.
Let's see, we are still live. There are 2 people watching.
I don't think it's running. Oh wait, no. Yeah, it's not running. Let me boot that back up.
I usually use like DigitalOcean or I host it on my own.
Yeah, it's hosted here because I can't easily get space somewhere outside of the network.
I usually host it on a machine I call Anton, which is a reference to the Silicon Valley show, the HBO Silicon Valley show. There's so Guilfoyle in the TV series, he calls his server Anton, so we named our server Anton for some reason.
I think it's more like 4.5 terabytes.
Yeah. So
that's mine, which is right around 1.5 terabytes. So we got about 6 terabytes rocking on the network.
Yeah. So yeah. So right now Anton is just like mainly mine's Ethereum, but as well as like other cryptos, but we yeah. Hello?
Yeah, hello?
Yeah, so but we're probably switching on other cryptocurrencies. There's a have you ever heard of Golem?
Golem isn't that's a what you call it?
Computation. It's a computationally sharing thing, right?
Oh, I haven't heard of that.
So yeah, so Golem is essentially a project so let's say you have a lot of GPU power, and what you can do is that you can sell your GPU power for GOLM tokens, Golem tokens. So users, they bid on tasks, and then once you receive a task, the network assigns you a task. You do the task, you are rewarded with and then once you complete the task, like let's say you're rendering a little part of a video or something, then once the task is complete, then you are rewarded with the tokens.
Is the like the task all self-contained instead of like a JVM type thing, like a virtual machine?
I'm not really sure about that part, but I do know that this I'm not really sure how it might keep its security though.
Yeah, it's gotta be an important thing because someone shouldn't just be able to like send something malicious over as a task and have that run.
Yeah.
That would not be good.
Yeah.
Yep, I was right. 1.5 terabytes for my computer.
I have a 4 terabyte NVMe on this stupid machine. Wow.
I'm gonna eventually get some better hard drives.
Yeah.
Hard drive.
This is excessive though. This is like, I don't need it to play Minecraft. Why do I even carry it around? But
I
you know.
almost got enough money to buy a graphics card for my server. Gonna be mining some more ETC.
You're gonna need to buy everything. Just buy like bulk.
Bulk?
Yeah, just buy it bulk.
What do you mean by bulk?
Just buy all your graphics cards in bulk.
I can only afford one for right now.
Oh, I see.
Yeah, I'll try to get maybe more money for more graphics cards. It doesn't even, the server doesn't even support a second graphics card. It's not that kind of motherboard.
Uh-oh. Oh, my glazed terracotta. So, I think this needs to go this way. Warp. Bones shop. Okay. Hello?
Yeah, one of the there's I think one service that uses TolerLFS, which is a music site, and it stores all of its music data files on there.
Oh. Wait, I heard that back in the old days, do you know like the Internet Archive project?
I think so. Yeah. A little bit.
Yeah, so the Internet Archive project, they used to use Tahoe way back in the day, but now they are now focusing more on IPFS, because IPFS for the wins. So yeah.
The only really Tahoe network I know of, because there's separate ones for all different things.
Yeah.
The I2P one, but I haven't really found any that are like public for the ClearNet.
Yeah. So essentially, by using Filecoin, I'm just making my own more efficient Tahoe IPFS.
Yeah, essentially.
Yeah. But like, there's no like hassle with servers. You don't need to do anything. You just need to run a program and choose what network you go on.
But then again, the interaction, it's not about how easy it is, it has to be the interaction for software integration.
Right, so let's see what are they using again? They're using, oh shoot, what are they using? Let me look it up on the Filecoin website. So Filecoin, let me see. Filecoin. I think it's so they're using two things. They're using proof of replication to prove that the data is physically stored, and second, they're using a proof of storage to prove that it's physically stored.
And just thinking about the proof that it's stored and stuff automatically goes to my head of taking the hash of the data,
yeah,
and then adding some kind of extra, or like not doing that, like
time.
So you know how it takes a hash, right, of the data so it can link it?
Yeah.
It then combines that hash with the hash that is found on the system of the data, the storing system, and then like some other random information so the hash can't be re-replicated. And then since the computer back at the computer checking that already knows the hash because it's pre-computated, and it would expect what the hash is on the output. If the hash is different from what it expects, then it knows that it's not storing the data.
Yeah. So they're using like a gossip system to retrieve the ask orders from the network, and then also and then they split the data into multiple parts, and then that's essentially how they do that. Hold on, we're gonna need to pause the live stream for about 2 minutes. We'll be right back. Sorry about that, guys. Yeah, just a little break.
Alrighty.
Always blue, always blue, always blue.
So I was thinking of a bunch of different ideas for a proof of work algorithm.
For what?
For just a crypto coin. Not well. You could use it for other things, but particularly like blockchain.
I see.
So you know how we just do the nonce and then we compare the hash so it's a certain, has a certain amount of zeros or whatever.
Like you check the SHA-256.
Yeah, the SHA-256, the SHA-1 coin.
Or you check the script, depending if it's
the ET hash.
Or check block transactions and stuff like that.
All this other stuff. As I was thinking is, do you know XOR, right?
Yeah, XOR, the Boolean thing.
Yeah.
Basically,
you can also use encryption for it.
So like.
Yeah.
So basically, like if both of them, it has to be only one of them has to be on. It returns true if only one of the inputs is on. If both of the inputs are on, then it returns false.
Yeah.
And if it's
similar. So you could do this with information bytes. It's kind of encryption. Some people think it's encoding. But when I was reading up on how DHT structures its nodes, where the nodes that you're close by, like let's say your node ID, normally a SHA-256 hash, that is like cut to a certain size.
Yeah.
You compare that with another node, and if the distance is like really, really low, then you connect with that, i.e. the difference between your two nodes is low.
Yeah.
So you do the XOR to measure it, and there's eventually, if you have like 100,000 nodes, there's eventually going to be one that you're really, really close to. Or if there's even 10 nodes, there's going to be one that you have the closest distance. So why don't we have a proof of work algorithm where we have we XOR it together, and for like the different block hashes. So you have the previous block hash and then the hash that you're looking for, and you're supposed to get it between a certain distance, closer to then a certain distance.
Like a probability?
Yeah, and since it's just hash, it's a probability that you're going to be in within this amount of distance.
I think. Let me check if that's. Are you like referring to like information, like storing like you can like indexing information use and then finding the hash from there, right?
No, not really. No, just between different blocks.
That
so you have to be within a certain difference of the previous block.
Yeah, that's proof of space-time.
Proof of space-time?
Yeah, that's in the Filecoin white paper. I post it in live.
Wait, so proof of space-time? I'm confused by this. Well, anyhow, I got another idea for proof of work.
Yeah.
Would be using AES, and I think they might have this.
Oh, AES.
For Monero to prove that you have a CPU that can support AES.
Yeah.
Essentially to keep down ASICs. But what I was thinking is you can use the previous block's hash, okay, which should be all known, to encrypt the next block. Okay? So you encrypt the next block with the previous block's hash, but you also have to have the nonce be in the block. So the nonce in the block.
The nonce?
So the nonce, not whatever I said. The nonce of the block that you're trying to work on needs to be re-encrypted and re-encrypted and re-encrypted and changed and then hashed. And then you check if it's below the certain difficulty, or it's above, not low.
Yeah, so
you'd be kind of proving how much you can do with AES.
That sounds. I think Monero might have implemented that. But that
it also It also like makes the blockchain on disk completely encrypted.
Oh.
You have to get the hash of the first block, then decrypt the second block, third block, fourth block, fifth block, so on and so on, forever.
The problem is, how do you make a system like that efficient? Like that?
Efficient being...
Because looking up, because let's say, because there's always so many competing blocks, right?
Yeah.
So running AES on blocks, I'm not really sure how that might work. Which block hash do you take?
Well, that's similar to back to Bitcoin, where they take whichever. They just take whichever, and whichever chain is longer, we'll get the competing. Will be the
But okay, let's say there's 2 chains, right?
Yeah, 2 chains.
Or maybe like even like several dozen chains, and they're all the same block length. What do you do? Which one do you choose? Do you just choose random one?
Well, if one gets longer, like it's bound to get longer. Someone's gonna solve the block before someone else, and then that one's gonna be the chosen chain.
Okay, so
and it's not supposed to break into a bunch of chains. It's supposed to keep on the main one, and you might have 2 blocks, you might have 3 blocks, right? But if one exceeds the others, and that's the chain that it goes on, and then all the transactions in the other 2 blocks get put back into the mempool.
I see.
Rebroadcasted in the mempool, and then it's reprocessed on the next block.
So you're just replacing the SHA-256 with AES, and then you're using the
AES, but still using a hash of some kind.
But then I think that's Monero. Let me check Monero white paper.
Yeah. Or you could have instead of like a SHA-256 hash, you could use something like the MTP algorithm, which splits the data into a bunch of miracle trees and then gets to a hash, but it's designed to be like memory hard.
I see.
And if you look where the memory tree is, or the miracle tree, you might be able to put nonces in certain spots, so it requires you to keep memory or information in memory for long periods of time when you're trying to work on a certain target. So you can't like retarget very easily because you have to do lots of pre-computation.
So yeah.
Might do
so let's see. Bitcoin. Let's see. So the Monero project. Yep, found it. Such function must not enable a network participant to have a significant advantage over another participant. It requires a parity between common hardware and high cost of custom devices. Because let's say you're mining on a mobile device and you're mining on a GTX Titan 1080. That GTX Titan 1080 is only about 2 times better than my phone. That's like, so they are very smart about that, so that everybody has an equal opportunity, no matter how much computational power you have, which is really important in the third world because they cannot process transactions if they have computers from early 2000s, but they can because Monero. For recent examples, we can see that the SHA-256 function was used in Bitcoin architecture does not possess a posterity as mining becomes more efficient on GPUs and ASIC devices while compared to high-end GPUs. So essentially they're using SHA-256 to make sure that everybody has an equal opportunity in the proof of work algorithm. So which is essentially what you were saying, right?
No, that's SHA-256 is Bitcoin, and Monero I think is something different.
So you're trying to modify it using trying to find the nuances in each block and passing that into the block file too. Or I guess the block. Yeah. Ow.
Oh wait, I was thinking about. Oh wait, I might have a problem. No, I figured out a way. Never mind. I was thinking because you know how we reconstruct blocks? We don't just send all the data in one string. We kind of like get the basic data and then we start sending the transaction bulk.
Yeah.
It would be kind of hard because the whole thing would be AES encrypted with 256. AS. It would be AS. So if you want to send to someone, you would have to decrypt all the transaction data and then re-encrypt that transaction data separately, and then send them away, and then they'll decrypt it with the proper information.
You think
it would be kind of problematic because if you didn't have that block, you would have problems.
Are you talking about like a diff-Hellman stage or?
No, not that. It's
Hello. We're talking about proof of work, and we're exploring how future stuff might use proof of work.
Yeah, it would be more kind of Monero like.
Yeah, so
because it's more like private.
But then
it'd also be super hard to monitor, or a little harder to monitor.
Yeah.
The outgoing information.
But that would require diff-Hellman, which would be really stupid because who's gonna exchange keys? This is decentralized, right? It's trustless.
No. Because it would be, you wouldn't be able to monitor the outgoing data, and I'll tell you why. Let's say they can if they went hard enough, right? Anyone who doesn't have the block data files can't decrypt any of the data because the encryption keys are the AES in the are stored on the hashes of the blocks, right? Like the last block was, let's say the 50th block, right?
Yeah.
The next one's gonna be 50 first, right? And the hash of that previous block is going to be encryption key for all of the transactions, well, just the whole block in general, the giant block file that was over size. And that gets moved over to nodes.
Okay.
It was transferred over.
That's starting to make more sense.
Yeah. So it wouldn't be like, you could still snoop on the transactions, but that's gonna be private because you could use the Monero's trying to think of it, the zero knowledge proof algorithm.
Like what? But I'm gonna say that ultimately, I'm gonna say that Casper is ultimately gonna win in the long term.
Yeah, definitely a proof of stake will win.
But then where do miners go? Do they miners? They might like go mad and then they'll create their own currency, but then nobody wants to use this currency because transaction fees are way too high, which is the irony.
Then that makes that's not. I don't think that has to do with transaction fees. Then that makes the competition to create a proof of work only coin that is amazing, that has all these different things.
Yeah, and then suddenly the Ethereum Foundation doesn't agree. No, screw you. And then suddenly there's gonna be like ether, ether, like cheese ether or something, like something stupid like that.
Yeah, some other thing.
Yeah.
But of course, all that GPU power, whatever they're using to mine, right? It's still usable for something.
No, just hook it up all to a Kubernetes node and then just hook it up to Golem. I mean, right now Golem is currently more profitable. If you, I tested it. I mined for 7 days. I turned off my machine and then I reinstalled Ubuntu onto it, not Ubuntu, Debian, and then I switched off GF and then I used the Golem testnet. I'm making more in Golem currently than I make in Ether, which is awesome.
Yeah.
So maybe we're gonna see a lot of off-chain and applications, and miners are gonna focus on the applications built on the blockchain itself, not necessarily on the blockchain.
Here's an idea. You can have. Well, this was an idea that I had a while ago.
Yeah.
I never really implemented it. Would be you have a blockchain and the proof of work is whatever. It doesn't really matter what the proof of work is.
Yeah.
But you have smart contracts or commands or whatever it is, whatever the position may be, where it has an output, and then the output gets written onto the blockchain. So you say, hey, complete this action, right? And let's say you're doing a consensus where you're trying to get this value, but not have anybody be able to lie on the value, correct? So
yes.
let's say I want to hash this file. and you send it out for everyone, and if you, let's say one person solves it, right? Let's say you're only sending it to one miner, they solve it, but they send back something invalid. You can't confirm if that's valid or not, so that's why you need a bunch of different people to confirm that it's valid. So let's say hash of this is...
You need more block... You need multiple block confirmations, essentially, right?
Well, you need multiple miners to confirm that. Whether about the block confirmations, because nobody's going to check if this is what it says. No like node is going to check if this bit of code outputs this. Like, let's say you have a bit of code that's designed to do a math calculation. The network is not going to confirm that, but the miners that are running, they confirm that, not the node software, because what's going to happen is if it's the network wants to try to confirm that, it's going to take large amounts of time. The blockchain is going to lag massive amounts of time because every node is going to have to confirm this calculation. So it's going to make it hard for different computers to do that.
Right.
So that's why if you had the miners, the people that are actually generating the work, confirm it, they'll put all of their proofs in a data file that is signed by their like address or whatever. You shove that into the mempool, and then whoever is mining the block, whether it's proof of stake, well, you're not really mining the block, you're just generating the block.
Yeah, that's
correct. Mining
correct.
is more or less done by the people who are calculating the task. That is, no one's gonna check if that's valid or not, but there's enough signatures from different people who mine the data that it says it's valid, so then it gets shoved back into the blockchain, the actual chain that's stored on disk.
So,
and you get your result back.
Yeah. So what happens?
If any miner lies about it, it will become invalid because the majority rules.
So, but the miners still have to have an incentive to do that, right?
Yeah, so that would be like a payment. So if, let's say you can solve that this is correct and the majority rules, right? Then you get the whatever amount of the output that you sent the money. Let's just say you sent a unclaimed output that is to the miners, that is split among all the miners that mined that information or confirmed it, calculated it.
Yeah.
So, kind of interesting.
Awkward silence.
Yeah.
Alright.
I
Alright.
was thinking of a decentralized like computer control system where you'd ask the computers that are on the network, say, hey, get me this file from so-and-so's computer. Let's just say you wanted to control the computers in your house, but you didn't want to have a central server. You can say, hey, node 1, give me this file, and then it will encrypt it and load it onto the blockchain.
That's basically so there's a lot of like things that are like into like networking. So the biggest one is Substratum right now. So highly suggested look into Substratum. But there's also another project called Siren Labs. Have you heard of them?
No.
So Siren Labs is making this technology. Basically, you can share computational power with your with other phones, and then let's say you want to control something, you could pass data along the network, which is more or less like a VPN, but there's a lot of competing technologies, but we don't actually know which one will win, because right now this thing is like a, it's like a how do I describe it, like a tide pool. 10 years from now, not all the fish, I mean like a year from now, not all the fish in a tide pool are gonna survive, but some of them are gonna pass on their but we don't actually know, but there's just so many creatures in the tide pool.
Like selective breeding.
Yeah. So right now we just need to, right now it's very hard to say who's gonna win, but it ultimately depends in ICOs and which and what investors think, because investors, they have the ultimate power.
Yeah.
Shoot, I'm breaking glass.
So my original idea that came from was like having a decentralized computation without needing to confirm if the information is valid, because if you're running the correct software, there should be no problem, right? Or
Right.
the miners are, there should be no problem. But I originally thought of that as being, or I originally thought the idea as being a decentralized like computer control system. You wouldn't have a control server or anything. The control, like how you control it is through a node ID.
Like an API.
ID, like a asymmetric key that you use to encrypt and sign data to the other controlled computers. So like you want to control your computer in your house or a server somewhere, you say, hey, can I have this log file?
Right.
And then it will take the data. It's designed to operate slow, not fast. It would operate over a period of a few hours, or not a few hours, like a few minutes rather than like instantly. But it will take that data, encrypt it, create, depending on the size. I don't know if it's going to be really large, what it's going to do for that, because you can't store a giant 1 gig file in one block.
Right.
Right. You might be able to create a link to it, like a link to some other way to store it.
Right.
But essentially small files or other like commands, so do like a command or something, a shell command or whatever. But it then will echo the output back into the blockchain, and it encrypts the information with the controller's public key, and then signs it by that particular computer's information. So no one
public
can see
key.
the information on the network.
Signs it with their private key, but then it can be proved using the public key.
Or the key of the
yeah.
owner.
So the action can be proved, essentially. So like proof of action. That's what you're suggesting.
No, it's not proof of action. It's designed to command whether the information is valid or not. It is kind of what you can say proof of action, but this is more like off from mining. Like mining is done separately, and it's done by the computers that are connected, right?
Right.
Like if I want to control my desktop, I'll say, hey, I have the correct authentication codes. Give me this file, or open whatever program, like open my web browser remotely. It will, you will encrypt and sign that information to that direct computer's node address, which will be the asymmetric.
Yeah, and then so the only thing that the user can do. So the only thing that what you're saying is that the user can sign a transaction, saying, using their private key, saying, I want this transaction done, and the origin server, or the server of action, will somehow receive that, and once it proves it, it will send the proof of action backwards, but using the same using their private key, so nobody can ever modify the command. They can only pass it along and receive a tiny transaction fee.
Well, how would they?
Yeah.
Maybe you can say it like that. But the whole idea was to be more or less command and control of like whatever computers, but you don't need any like software or servers that actually store hard data on disk, like logs, for example. All the logs are stored on the decentralized blockchain, by the blockchain of different that are spread across all the system.
That makes sense.
So you would have like I think that's what it was going to do, or what it was supposed to do, but you'd have DHT to map out the network.
Yeah.
I don't know what I was planning on for the DHT to be used in it. But
yeah, so basically it's like all encrypted.
Yeah.
Yeah, I was thinking like you could have a peer-to-peer network, but wouldn't you have to like worry about like man-in-the-middle attacks or something like that?
So essentially, what he was proposing is that you have to sign the action using private key and public key encryption, and so you can check that the action has been done, but you can never modify the actual contents of in the middle man in the middle attack.
View or modify.
Yeah, so
you might be able to modify it, but since it's like if it was just encrypted, you can modify it, but you wouldn't be able to
sign it.
Be able to do anything because it has to be signed. It wouldn't. They'll say nope, invalid because it's not the owner of the network's key. It would say it would be like node blah 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 blah.
Yeah.
And it would be like no, that's untrusted.
Yeah, it's
and the trusted keys will be hard coded in like the first block.
Yeah. So like what you could do is like it's like very similar to what Ethereum sees when someone tries to sign a transaction with a faulty private key. They said nope, get out of here, you're fraud.
And with Bitcoin.
Yeah, but then the blockchain, the miners, or so-called the people that pass a thing along, they also have to receive transaction fee, right?
Yeah. Or the people that mine the block that contains the data, because the map pool is all shared among the nodes. And I don't know if there's a relay fee or not, but I don't think it should be too much because like a transaction is only like what, 400 bytes. You know, that's not going to use too much internet if you're just relaying that.
Yeah.
There's, of course, like maybe a few hundred bytes of overhead, but that's not too bad.
I mean, this looks
maybe like a kilobyte.
I mean, you could literally just like fork Raiden Network's peer-to-peer system, and then like do a different like daemon or something, some public private key basic encryption, and then set it up so that you can send it up. That's basically Scuttlebot, but that's written in.
Yeah, I was on Scuttlebot before.
Yeah, yeah.
I tried it out for a little bit, but I didn't like how like you made a comment and then you couldn't delete it.
So that's actually the application. We're actually talking about like the underlying protocol. So there's a social media running on top of Scuttlebot, but we're talking about the we're talking about the underlying protocol that relays those messages to each other. Yeah.
You know what my favorite protocol was? The Infinite Monkey Protocol.
That's a good one.
Yeah, I always wondered how you could make a cluster of computers, like, generating, just some dummy text and somehow assemble that out of it.
I see.
But wouldn't that be like, sort of like a neural network or something?
So, a neural network is a basically a computer is learning by having a oh gosh, I can't explain it. Do you want to explain it, or?
Nah, I know. I have a basic idea.
Yeah, it's just a bunch of points of data that can recognize patterns in data. What we're talking about is that actual computers, not points of data. So yeah, I mean the analogy is similar, but they're just totally two different parts of computer science. Hopefully that makes sense, right?
Yep.
I know, we're just spewing out total nonsense. Yeah.
Me, I'm not that smart. I mean, I'm smart enough to run a web server on my Raspberry Pi, but I mean, I do know a little bit about peer-to-peer applications. I mean, I've tinkered around with IPFS a little bit.
Oh yeah, IPFS, yeah. So, looks like a lot of people know about IPFS. Yeah.
I'm also on ZeroNet now.
ZeroNet, yeah. ZeroNet's pretty... They're okay, I guess. Oh my god, I'm so sleepy. I just wanna collapse, but I have to stay awake. This live stream is still going on.
Yeah, there was some guy complaining about how IPFS doesn't really, I mean, not IPFS, but ZeroNet doesn't really
scare. Right?
very well.
Yeah, 5 days straight live stream. Yeah.
Great.
No, like as in like there'll be live streams like throughout 5 days. Hold on for a second.
Sorry if I was talking over you. I apologize for that.
Okay, guys. It appears that we have to cut. Okay, guys. It appears that we have to cut this live stream off. We will be back. I'll be back in about maybe we'll see. Maybe 7 or 8, 7-ish. But I will be. But we will. It'll be updated. So yeah. So yeah, nice chatting with all of you guys. Very good conversation. So I will see you guys all next time. If you guys want to leave a like, comment, and subscribe on the live stream. Also, please make sure to hit the notifications button up in the top right corner. And I will see you guys all next time. Bye!